Don't remember how to do this? Don't worry, I got you. Basically, the whole point is we have to find out what value x has to be to make these two expressions actually equal to one another. So, in my notebook, I wrote 3x minus 5 equals 10. Remember, this is where you put the line down the middle, and you always do the opposite of what you have. So you always start with the variable side, because here I have a variable side and I have a number side, and I want to get the variable by itself, so I'm going to put all the numbers on this side, but anything I do to one side, I have to do to the other to maintain equivalence. So I'm going to add 5 on both sides. Now remember, it's both sides so that you maintain equivalence, and the reason why we do this is because if I have a negative 5 plus 5, that's going to cancel out. That's going to give me 0, and then you get 3x equals 10 plus 5, which is 15. Now we got to get rid of this 3. But we're not subtracting 3 or adding 3. This 3x is being multiplied, right? So 3 times x equals 15. Most of us already know this. 3 times 5 equals 15. But the process goes that we want to get 1x. So what I'm going to do is divide by 3 on both sides. Again, that's the inverse or the opposite of multiplication. And we get 1x equals 5. Now, we know this makes sense, or this is correct, because if you have 3x minus 5 equals 10, and let's say that, yeah, x is 5, so I'm going to substitute x for 5, 3 times 5, minus 5 equals 10, you get 15 minus 5 equals 10, and here you get 10 equals 10, which is true. So x equals 5.